Hey guys, welcome to the world of software testing, and this time let's talk about equivalence partitioning. Actually, this is the most simplest and one of the most efficient software testing technique, and every software tester should know it. Okay, how does it work? Let's see an elementary example. Let's assume that we need to test a console-based application, and this application decide whether a number is even or odd. So if we give the input 2, then it prints this number is even. If we give as an input like 9, then we see this input is odd. And if we insert a special character or any other input as a positive integer number, then we see that this is an invalid input. Okay, what kind of test cases should we design it? Probably your first thought is let's test the 0, let's test a very big number, a very small one, some kind of special character, or let's say 1.2 or 1,2 with different formatting, or what happens if I give more inputs. But wait a minute, what do you think? How many input exists? Please note that I can write to anything. Of course, practically infinite. And obviously, I cannot test everything. If you remember from the previous video, then exhaustive testing practically is impossible. But how can I decrease the number of potential test cases? Somehow, I need to define different behaviors. And this is the basic idea of equivalence partitioning. We need to define input groups. And this input group, for example, the even numbers, is an input set. And every even number produces the same behavior. Similarly, every odd number produces the same behavior. And of course, the third category, every other non-positive integer number produces an invalid input message. So based on the specification which I described in the beginning of the video, then we described that three different behaviors we have. That means that we need to test these three behaviors at least once. And this is the basic idea of equivalence partitioning. Then let's define these partitions, these input groups, and we need to test every input groups at least once. Please note that within a partition, every element behaves in the same way. So 2, 4, 6, 12, 20, these are even numbers. So the app should write, then this is an even one. This means that you need to define a partition, then think about that those elements should behave in the same way. But please note, we only assume it based on the specification. And always start to think how many different behavior exists. In this case, we have three different behavior and we need to test every partitions at least once. So pick one element from the even, one from the odd, and one from the invalid one. So let's test 2, 5, and a special character. So these three test cases has a good coverage, and we test all positive scenarios and one negative invalid one. Why this test set is better than the original one, what I listed in the beginning? First of all, our original test set doesn't contain the positive behaviors, which is crucial, so we need to test, of course, the even and the odd. And these ones only test the invalid ones, okay, more deeply, but we miss the odd and even, so this 3 is significantly better than the another one. Okay, but wait again. You can say that, oh no, okay, even and odd can be added from the original one, but of course these lot of negative scenarios are much better because you test 1.2, different formats, more inputs and so on. You're right, but actually you can divide a partition to more subpartitions. In this case, for different formats, for example, and if you divide it, then you need to cover the subpartitions too at least once. So in this approach, you can refine your initial partitions. Okay, and we have one more thing, the equivalence partition coverage. What is a coverage? We can measure how many partitions are already covered. If we have already tested the even partition, then our coverage is 33%. If we have tested the even and odd, then the coverage will be 66%. And if we test all three, then our coverage is 100% equivalence partition coverage. As you see the pattern, simply we could calculate the tested partitions divided by the all defined partitions. Actually, this is a general rule you will see in when we talk about other testing technique, that you can calculate partitions with this formula, so tested divided by the all defined partition. Okay, but believe me, this is the simple example and it could be much more complicated. What happens if we have more independent values, whatever, but you need to understand the basic concept with this even and odd number problem. Okay, I hope you enjoyed this video. If you are new here, please consider subscribing. Please leave comments, suggest me, recommend me any future topics, and thanks for watching.